Are you ready for today's lesson? Are you really ready? Let's start. I know, I'm overacting a little bit. Today we're going to talk about the periodic table. The periodic table is, as you see it on the screen, you see that you have all the elements, the recipe to do everything, the basic ingredients to do everything that you see around you are located in this table. And the arrangement is also easy to identify. You can easily see that there is a consecutive number on top of each elemental symbol. So let's go to the basics. In here, we see, if we take this example over here, we see that on each square we have the elemental symbol, which will be one capital letter or one capital, one lowercase. Always like that. So this is one with only one capital letter, and down below we see lithium, which is one capital and one lowercase. On top we have what is called the atomic number, which corresponds to the number of protons. So if somebody asks you about what element is this or that, all that you need to know is how many protons this element has. It's like the social security number of every element. So the social security number for aluminum will be 13. So the only element in the whole universe with 13 protons will be aluminum. Or let's say that you go to Mars and you are sampling something that has 7 protons. If it has 7 protons, it's going to be nitrogen, no matter what. So the number of protons will determine the identity of the element. So keep that in mind. That's the social security number of the element, the number of protons. Oxygen has 8 protons and so forth. Now, if you look below the elemental symbol, you will find a set of numbers with some decimals. These numbers correspond roughly to twice the atomic number. I said roughly because this number is calculated, the atomic mass is calculated based on an average of the natural isotopes of each element. So that's why it's not going to be a whole number. It's not going to be 28 or 27. It's going to be a decimal because it's an average. Depending on the percentage of each isotope in nature, you will have the possibility to have a bunch of decimals. But in here, they will give you up to 3 decimals. So this is the atomic mass and corresponds to roughly twice the atomic number. I'm afraid to say that this is somehow a little boring periodic table because it's not colorful, it's just black and white. The only contrast in here that you can see is this dark line. This dark line is to separate metals from non-metals. Whatever is located to the left is going to be a metal. Whatever is located to the right is going to be considered non-metal. But there is one exception. So we have anything to the left is going to be a metal, almost anything, and everything to the right is going to be a non-metal. I said we had one exception. This exception is hydrogen. This is our little renegade here. Hydrogen, although is in the metallic side, is on the metal side, hydrogen is a non-metal. So in your mind, you're gonna cut this hydrogen and you're gonna bring it to the non-metal side. So don't forget that. It's a common mistake made during testing is to consider hydrogen a metal, but remember, it's the only exception to this division between metals and non-metals, hydrogen, which is a non-metal. Now I'm going to mention some of the famous groups in the periodic table. The first group I want to talk about is the Alkali Group. This alkali group, you have to handle it with extreme care. Alkali group. This alkali group is very special. These guys are extremely reactive. You need to handle this with care. They are so reactive that when you place them in contact with water, you can even see an explosion. That's how reactive they are. So this is by far the most reactive group in the periodic table. Another hint that you may notice already is that the guys that are located, the elements that are located in the same column, they share similar chemical properties. So if you are looking for instance, at nitrogen, right here, if you are looking at nitrogen and you want to find an element that has similar chemical properties as nitrogen, you need to look at the same column. Don't get fooled choosing elements that are to the sides. Even though they are almost touching the nitrogen, they don't have similar chemical properties. When you look for similarities, you need to look at the columns. In this case, a good choice for similar chemical properties will be phosphorus, arsenic, and so forth. You need to look at the column. Okay, so let's go back. This is the alkali group. The alkali group, they are highly reactive. And of course, they are metals. Remember that with our minds, we already cut this hydrogen and put it somewhere over here. So I'm talking from lithium to francium. All right. Our next famous group is going to be the alkaline metals. You see, these guys have a very similar spelling as the group before, just adding Ne at the end. So these are also metals, of course. They are also very reactive, highly reactive, but not as much as the alkali metals. So alkaline are still very reactive, very fun to play with, but they are not as reactive. They are not so violent when they react as the alkali metals. So alkaline, another famous group. These guys are next door of the alkali, but they are slightly less reactive. Another famous group is the transitional metals. You can see these guys in some textbooks as transition metals. Others use transitional. I really don't have a preference. So these guys are this. So it's a huge block. So this is the group that corresponds to the transitional metals. Some of the special properties they have is that they can have different oxidation states. We will talk about oxidation states in a later lesson, but for now, just consider them as a special group that can have different oxidation states. Another famous group corresponds to the halogens. They are very special. They are also very reactive. These halogens, they really look around to have somebody to share or to steal one electron, because they have 7 valence electrons. We'll go in more detail to that when we analyze bonding, but for now, just keep in mind that this column, the halogens, they are also reactive. Our last famous group will be the noble gases. Noble gases are very special because they do not react under normal conditions. To see these guys reacting, you will need a lot of temperature and a lot of pressure. So under normal conditions, you will not see these guys doing anything. To me, they are boring because they do not react. So we have like two extremes here. On the far left, we have the most reactive group, and on the far right, we have the least reactive, the ones that do not react at all. Those are called the noble gases. Noble because you don't see the novelty, the the king, the queen, the prince, the princess. You don't see those guys mixing with anybody. So when we say these guys do not react, that means they don't mix with anybody. So that's why they are called noble gases. I think that's the reason. So just another fact to remember. These guys, they don't react. If you have a periodic table next to you, my recommendation right now will be to pause this video for a minute and label these groups. Go ahead and label the alkali and use a highlighter to highlight the alkali. Do the same with the alkaline, transition metals, halogens, and noble gases until you become very familiar with them. Until then, I will use like my personalized periodic table to work around my chemistry problems. Now let's talk about the basics, the very basics of bonding. It is commonly seen on state testing that students are required to identify a bond as ionic, metallic, or covalent. So let's mention this really quick. The first bond I'm going to, sorry for the noise, the next bond, the first bond I'm going to talk about is the ionic bond. This is very easy to remember because ionic bond are the bonds between metals and non-metals. So when you have one of each side, there you go, you have an ionic bond. So all that you need to see is one of each side, one from the non-metal group and one from the metallic group. That will give you a ionic bond. A very common example could be sodium chloride. So we have sodium and chlorine. Sodium, of course, is considered a metal. It's on the metal side because it's to the left of this dark line. Anything to the left to this dark line is going to be a metal. So sodium is a metal. And chlorine, of course, located to the right of the dark line, is going to be a non-metal. So when you have a metal bonded to a non-metal, that is going to call, of course, that's going to be an ionic bond. On the other hand, we have covalent bonds. Covalent bonds are those between non-metal and non-metal. So when both of the elements are located to the right of this dark line, remember that hydrogen is also a non-metal. You can bring this hydrogen and bring it over here. When you have two non-metals together, that is a covalent bond. In this case, we have oxygen bonded to oxygen. That's molecular oxygen, that's O2, because we have in here non-metal with non-metal, that's going to be covalent. But in addition, because you have the same element together, we will call that covalent bond pure covalent bond. So we have a pure covalent bond with this diatomic molecule, O2. Now, when we have carbon and oxygen, for instance, carbon and oxygen, we still have two non-metals because they are located to the right of the dark line. So this is still a covalent bond, but because it's not the same element with itself, it's going to be called polar covalent bond. So this is just to add a little bit of information to the classical distinction between ionic and covalent bond. Covalent bond could be pure, like in this case, oxygen bonded to oxygen. You can also have fluorine bonded to fluorine or chlorine bonded to chlorine and so forth. So when you have these diatomic molecules, same molecule bonded, same element bonded, you will have a pure covalent bond. When you have different, like in this case, carbon-oxygen bond, they are considered covalent, but in addition, they are going to be called polar covalent bonds. The last type of bond that we are going to review is going to be probably the easiest to remember, metallic bond. I'm going to let you guess, of course. It's going to be when you have metal bonded to a metal. So when you have two elements from the left having a bond, those guys will be considered to have a metallic bond. So let's review. When you have one of each side, when you have one metal and one non-metal together, that bond is going to be considered ionic. When both are non-metals, that bond is going to be considered covalent. And when you have two metals, of course, the bond is going to be considered metallic. Okay, this video was intended to touch only the basics of the periodic table. On a separate video, I'm going to talk about valence electrons, I'm going to talk about trends, and other cool stuff. So stay around and check another periodic table video. This is just the basics. See you.